Good day everyone. We are Group 10 and today we will be presenting our project entitled Technical Design and Layout of an Ethyl Acetate Production Plant. This project was prepared for the course DAK 10502 Engineering Drawing under the guidance of Dr. Bashira binti Fauzi. Ethyl acetate is an important organic solvent widely used in industries such as paint, coatings, adhesives, pharmaceuticals, and product processing. In this project, we focus on the technical design and plant layout required for the efficient production of ethyl acetate. Throughout this presentation, we will explain the introduction to ethyl acetate, the production process, equipment selection, plant layout design, safety considerations, and environmental aspect related to the operation of the plant. We hope this presentation provides a clear understanding and how an ethyl acetate production plant is designed and operates. Thank you, and let's begin with the first section.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shawal Hazimi Bisaidi and my number metric is AA251490.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zainul Arifin bin Muhammad Fali Yusof. My metric number is AA251145.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamir Aiman bin Abdul Muiz. My number metric is AA250298.
My name is Sukeshwan Analaki Kaleselvan. My metric number is AA250022. Thank you.
Alright, now I'm going to give a brief introduction of ethyl acetate. What is ethyl acetate? It is basically a clear, colorless, highly volatile organic ester liquid at room temperature. It features a distinct, pleasant fruity odor, a moderate polarity, allowing it to dissolve a vast range of organic solids and a boiling point of approximately 77.1 degrees Celsius. Of course, as it is a chemical substance, it is a greener alternative for some of the substances that are widely used in industrial and manufacturing. It is because it is significantly less hazardous to human health and the environment than chlorinate and some chlorinated solvents of or aromatic hydrocarbons, and it is highly preferred as a greener alternative in modern manufacturing. For the industrial for the from the industrial view, they need to design a dedicated production plan respond to the global mandate for sustainable chemical manufacturing. The proposed design addressed traditional high energy consumption caused by minimum boiling isotopes, pushing commercial purity levels past 99.5 WEC percentage while prioritizing thermal efficiency. For the strategic industrial benefits, it reduced dependence on imports product by ensuring a steady, localized supplies of a high demand commodity solvent, while also utilizing ethanol derived from agricultural biomass, so that it is safer for us to use and also a safer alternative for the environment. It serves as a bridge between traditional processing and renewable biorefinery ecosystem. Now, from the perspective of the industrial demands and market demand, because this product ethyl acetate is so versatile, the global demand for it is massive and growing each day. You probably interact with the product made using this thing as ethyl acetate every single day without even realizing it. First and foremost, it is a major ingredient and in paints, coatings, and varnishes because it helps them dry quickly and smoothly. It is also widely used in the printing industry for inks and the packaging industry for adhesive and glues. But it's not just for the heavy industry. In the cosmetic industry, however, it is a main ingredient to make nail polish remover. And in F&B industry, food and beverage industry, it is actually used to decaffeinate coffee beans and tea leaves, and it's even used as an artificial flavor enhancer. Now, because so many industries rely on it, building an efficient production plant is a highly profitable and essential venture for us by using acetate as the main supply.
Okay, next, I will explain the chemical reaction and production pathway for ethyl acetate production. The main industrial method used in the Fischer esterification process. In this reaction, acetate and acetic acid react with ethanol to produce ethyl acetate and water. The chemical equation shown illustrates this reversible reaction. To increase the reaction rate, an acid catalyst is required. Industry commonly use sulfuric acid as a homogeneous catalyst or acidic ion exchange resins as a heterogeneous catalyst. One challenge of the process is that the reaction is limited by chemical equilibrium. This means not all reactants are converted into products. Therefore, industry improve the yield by using excess ethanol and continuously removing product from the reaction system. These strategies help shift the equilibrium toward ethyl acetate production, making the process more efficient and economically viable. Okay, let's move on to block flow diagram functional description. And now I will explain how the block flow diagram for the acetate production process. In block 1, fresh acetic acid, fresh ethanol, and recycled reactants are fed into an esterification reactor. The reaction takes place in the presence of an acid catalyst to produce crude ethyl acetate and water. In block 2, the reaction mixture enter an azeotropic distillation column. This unit separates volatile components as an overhead vapor while heavier unreacted acetic acid remains at the bottom. In block 3, the condensed vapor is sent to a phase descenter. Due to the density difference, the mixture separates into an organic phase and an aqueous phase. Finally, in a block 4, the aqueous phase enters a recovery distillation column. Unreacted ethanol and residual ethyl acetate are recovered and recycled back to the reactor, while water is discharged as a byproduct. This process improves raw material utilization and increases overall production efficiency.
This process starts with two fresh feed streams, liquid ethanol and liquid acetic acid, which flow from their storage tank into the continuous reactor. Inside the reactor, they react to produce ethyl acetate and water, while some reactants remain unreacted. Next, the reactor effluent enter the azeotropic distillation column. At the top of the column, a vital azeotropic mixture of ethyl acetate, water, and ethanol is sent to the descenter for phase separation. In the center, the mixture spread into two layers. The bottom aqueous phase is sent to the recovery column, while the top organic phase, which is rich in ethyl acetate, is sent to the product distillation column. In the recovery column, unreacted ethanol and acetic acid are recycled back to the reactor while the purified water is discharged as wastewater. Finally, the product distillation column purifies the ethyl acetate and the final high purity product is sent to the product storage tank.
I will explain the unit operations and equipment functionality used in the production process. First, the continuous drift tank reactor is used to continuously mix the fresh feed and recycled streams. An internal agitator ensures uniform mixing, while the heating and cooling jacket helps control the reaction temperature and maintain stable operating conditions. Next is the azeotropic distillation column. This column separates the mixture based on differences in volatility. The lighter and more volatile component move upward, while the heavier components remain lower in the column. This helps improve product purity and recover unreacted materials. The mixture then enters the liquid descender. Here gravity separation occurs because the liquid phases have different densities. The lighter organic phases is collected from the top, while the heavier aqueous phases is removed from the bottom. Finally, they are the product and recovery distillation column. The product column removes any remaining metabolite, impurities, and product high purity ethyl acetate. Meanwhile, the recovery column recovers valuable unreacted ethanol for reuse and remove clean water as the bottom product. In conclusion, this unit operation work together to ensure efficient production, high product quality, and reduce waste through material recovery and recycling. That concludes our presentation on the production, process and equipment functionality of ethyl acetate manufacturing. We hope this presentation has provided a clear understanding of the process, key unit operation, and their importance in ensuring efficient and sustainable production. Thank you for your attention.